So let's look at a rolling window evaluation for an MLP model this time. And we're going to review the WT Crude 2020 for this example. So there is WT Crude 2020. In the previous videos, we've looked at an AR1 type MLP model that's simulating or resembling that AR1, but it is an MLP with one weight and one theta. But just to review our strategy here, what we will do is have many windows where we will evaluate this model many times and then take the average of those evaluations. So the first window will have a trailing set of 9, and while this is a little bit wider than 1, it's supposed to represent 1. So at the end of the day here, we will have we'll have that residual, we'll square it and take the square root, that's the RMSE, but since it's only a horizon of 1, it'll just be the residual. So then we will use that same model. I guess it's should be the implementation of this is we used all of this data to estimate this W1 and that theta. And so then we're going to go back and see how well it would have evaluated over the entire series. So again, we'll plug in essentially just one back. This is a training size of 9. And it really, because of the model here is only looking back 1, it only needs to be 1. However, for some of the ways NN4 and MLP function work, it tries to do a lot of things automatically, and it uses the first 9 to essentially do a exponential smoothing model to see if it needs to add trend. So there's a lot going on behind the background in the NN4 MLP function that requires us to have at least 9 here. So that's why this is 9. The horizon is 1, so the whole window would be 10, and then we'll advance it 1, and then get another RMSE, see how well it would predict that value. And we're not refitting the model each time. We refit the whole model once. And then we would do another one and then see how many times we can go across the entire series, each of these generating an RMSE. And it turns out at the end of the day, we will, for this WT Crude 2020, we will have generated 363 windows. And then the total RW RMSE, the rolling window RMSE, is the average of the RMSEs from all 363 windows. So that's what this function will end up doing. On back over to our studio, where we have plotted the WT Crude 2020 data, and we wanted to again fit that AR1. So we will all see the same results. We'll go ahead and set the C to 1, but this is the AR1 fit that we want to evaluate using this rolling window mechanism. So we'll go ahead and fit it. Like I said, we're going to use all the data to fit that one weight and that one theta. We just did that. We plot it, do a little sanity check. We got a very simple architecture. Here are those 5 reps. The final estimate there was a very small theta and about a 0.718 for the weight, which is kind of analogous there to the Phi1. And now we'll do the rolling window fit. So notice we got rollwin.rmse.nn.wge, and what that does is it remembers these 2 weights and goes back and uses those same weights to estimate 1 ahead. Notice the horizon here is a 1. You can set that to be whatever you like. So it looks at 1 ahead and comes up with a forecast, and then looks at the actual value since we have that and versus the forecast, and squares that residual, then takes the square root. Since it's h equals 1, it's just the residual anyhow. But if you had h equals 2 or 3 or 4, it would add those squared residuals together, then take the square root to get the RMSE, or take the average of those squared residuals, and then get the take the square root and get the RMSE. And then notice this fit model equals AR1 fit down here. That's what's passing it those weights. That's where we say, hey, just take those weights. We don't need to refit each time. We've already fit it once. Let's evaluate this single model over the entire series. And so we'll go ahead and do that here. So we do that, and it's off to the races. It sees it's got 363 windows here. That's with a horizon of 1 and that trailing set of 9. And this is a histogram of 363 RMSEs. And the reason we put that on there is for some windows, it was really good prediction, right? It was almost 0. For other windows, it really missed. And you can kind of compare this. It doesn't mean a whole lot. It gives you a little bit right now, but once you compare this, we'll run it again here in a second with an AR2 type model, which is still an MLP, but trying to do something similar to an AR2. But you can compare those, and you can kind of see overall the windows how you expect this to perform, this model to perform. So at the end of the day, though, we will look at the RMSE, the rolling window RMSE. That's the mean. You can see that there. That's the mean of those 363. But you might choose to use the median. Right? The median's a little bit lower there. This is a right skewed distribution of RMSEs, and you've got the 5-number summary there as well. So however you want to evaluate, you've got the ability to look at a variety of statistics with respect to the RMSE. We're going to look at the mean of those, and that's 3.624. So how might you use this? Well, you might use it to compare the fit of another model as an AR2. Maybe looking 2 back. What is that? We've got various things, AIC, BIC. We have other ways to evaluate models, but one of them, and maybe in my opinion, there's none better than a cross-validation statistic. So I'll go ahead and set the seed here. Notice that this is now using 2 lags. That's the only difference between those 2 models. It's just looking 2 back. We can go ahead and run that, and then verify that the architecture is as we think it is. That's xt minus 1, that's xt minus 2. And we'll go ahead and look at those weights again to verify. There's the theta, and then there's the weight 1, and there's weight 2. And we'll say, hey, how well does that model work? And notice we're passing it AR2 fit here. That's all that's doing there is passing it these weights. It's passing it that model. It's not refitting the model each time. Horizon of 1, I'm gonna give it the data, and it zooms past. But now it's got to look 2 back. But still, that trailing session was 9. So until we get up to like an AR9, it's going to keep us with 363 windows. And I say an AR9 until we're looking 9 back. So this one was rolling window mean RMSE of 14.734. And so there you would have some evidence to lean on the fact that maybe a more parsimonious model that just looks at yesterday is better than one that looks yesterday and another day back. And you can again see these 2 histograms here. There's the first one, looks a little more right, a little more towards 0 there. Again, the mean, I didn't see the median. Let's look at the median. Come back to this one, right? It's kind of getting up there. They look pretty similar, but at the end of the day, right, that's an 11. The other one was a 10. And there's, again, just various ways you can compare these. But that is a rolling window implementation and evaluation of an MLP model using roll.win.nn.wge. Great job. I hope you're having a blast. This is a lot of really fun stuff, and I'll see you in the next one.